So, as we are still working with our August 2025 exam, we are given this is question number 4, which is part of our differential equations. So, that is 4.1. We were given to find the general solution. So, we are dealing with the general solution of dy dx, which is equal to this part. All right. So, we're given that the derivative of y with respect to x is equal to that, and we had 5 marks for that. Okay, so let us consider our question. Dy dx is equal to 2y minus 3x plus 1 everything over x, and what we need there is the general solution. From the presentation of the differential equation, we can note that because of this dy dx that is not raised to any exponent, like to the exponent of 2, but raised to the exponent of what? Of 1. It is the first order linear differential equations. All right, the first order linear differential equation, which we do understand that we must solve, or we must have our solution by separation. We must be able to separate the variables that we are given, x and y, in the format that we are given as dy dx plus py is equal to q. All right, so this format, we are given it, or we have it from our formula sheet, in sec that in case you have forgotten this, you can check out from your formula sheet on this part. This part that we are given of dy dx plus py is equal to q. This part is the one that you use whenever you are solving the first order linear differential equation. This is for the first order linear differential equations, where we are given p and q as functions of x. So we must have p in terms of x, q in terms of x, so that we can determine what we refer to as the integral factor e to the exponent of this, which represents the integral factor. We're going to look into that one later on. But as you can see, the format is already there. So if you're someone who have forgotten, you can still work out with the formula sheet. So let's try to separate to obtain this condition, dy dx on its own. Then we have p, which is in terms of x, and q, which are in terms of what? Which are in terms of x. So how is that possible? There is only this part of y that we are given here, the 2y. This is the only part that we have. So we can actually take this remaining as a single term. It is an expression. I know that it is an expression, but we are going to treat it as a single term, as a single unit, so that we can separate. Remember, I explained before, a plus b over c is the same as what? A over c plus b over c. So meaning to say, we can separate this now as dy dx is equal to, so we have got the 2y affected with x, which is our denominator. So that's 2y over x. Then we have got plus, we separate this. So this one is same as minus 3x plus 1 over x, which is same. We can start with a 1. So it's going to be 1 minus 3x over what? Over x, as a single term, or as a single unit. As a single unit. So this here is in terms of x. We do not have y there. We are not worried. Here we have got y, a single part of y. So this is what we want. So separating now because we need this format. dy dx plus py. So we are going to take this part which is having y, this one, 2 over xy. So this is our p, 2 over x. Remember, it must be in terms of x. So we're going to take this one with y as it is to the left hand side. So it will be a negative. So that's plus. All right. So we've got plus here. Then we have got the negative 2 over x, all right, with the y there like this. So here I'm just writing in a way that we can all understand in terms of the format plus py. So this is our p, this one. That is in terms of what? In terms of x. So you can properly see the dy dx on its own plus the part of y on its own. So what are we going to need? On the right hand side, as we can see, it is the part which is of what? Q, which is also in terms of x. So this is the part that is remaining here of what? Of Q, which is in terms of x. So this is it. The P is in terms of X. The Q is also in terms of X. So what is it that we are going to need from these two? We are going to need what we refer to as the integral factor. So the first step was to find, was to rewrite in a format, the normal format that we are used to, all right, which is this format. From this format that we are seeing here, it simply tells us that we have got P and Q separately. So you are going to determine or to find what is referred to as the integral factor. So the integral factor that we are talking about is the one that we are given as e to the exponent of px, which is p is in terms of x, which is from our formula sheet. I was indicating this part of e to the x, but this one, it is your integral factor, this one. It is the same thing that you see here on the right hand side. It is our integral factor. So as we can see, in order for us to have that e to the exponent of, we can just have it stage by stage. We integrate this part on its own because this is our p, the integral of p. We determine this integral, then we can determine our integral factor. So let us just have the integral on its own, which is the integral of what? Of p with respect to x. So our p is negative 2 over x. So if we integrate this, remember 1 over x gives us the ln. So it's going to be negative 2, the ln of what? The ln of x, which is the log of what? Of x, plus the constant of integration. So this is our integral, which the ln as a log, remember there are laws, concept that we can use. A log b, we can have the a to be an exponent. So it is the same even for a ln. If there is this negative 2, which is multiplying the log, we can raise it to be the exponent. This is just rewriting, guys. So it can be written as the ln of x to the exponent of negative 2. Apply your laws of exponents. So that's 1 over x squared. So this is our integral of p. This is the p dx that we got there. So this is the one that you are going to put here. Okay. So it therefore tells us that our integral factor at the end is going to be given as e to the exponent of what we integrated here, p with respect to x. We got ln 1 over x squared. This is what we got. So you were supposed to substitute as it is into this formula that I have showed you guys from your formula, this one. You were supposed to take that, substitute as it is. But before we do that, we can see something that is common in our simplification here. The e raised to the exponent of a ln, an exponential to a log. If we are given that condition, e to the exponent of ln of a, it is neutralizing. Remember, exponential is the inverse of a log, which is our ln. Ln is also the inverse of an exponential. So meaning to say we are just neutralizing. Our answer is going to be equal to something. E to the exponent of ln something is supposed to be equal to that something that you're given. So in our case, it is e to the exponent of ln something, which is 1 over x squared, this one. So our answer is going to be that part which is under a ln, which is 1 over x squared. It is one and the same. All right, just like let us just take our calculator. Okay, let me go back to the normal mode. All right, so with our calculator, let us just say e, this is e here, to the exponent of ln. Let us just put any number there in ln. You can put 8, you can put 10, whatever number that you want. So we are saying if this is e to the exponent of ln of a certain number, this one, which is what? Which is 8. Our answer is supposed to give us 8. That's something that you're given there. So is that true that our answer here is going to be 8? All right, let's see. That is going to give us exactly 8, as we can see. So e to the exponent, if this is b, this is going to be b. If this is 10, this is going to be 10. So if it is 1 over x squared, 1 over x squared again, that is the concept that I'm simply referring to. So let us consider that on our simplification. Since this is our integral factor, I'm going to rewrite that part here. So remember, we said from this whole presentation, we are going to have therefore y, all right, as it is here. I'm going to take this part as it is this one. All right, so I'm just going to rewrite that part as it is. Then we can change and write in the way that we understand. So it is given as y times e to the exponent of p dx, which is equal to the integral of q e to the exponent of the integral of p dx with respect to x. So I'm saying, guys, we have simplified this thing here, the e to the exponent of this one. This is our integral factor here that we're simplifying. We have it. That is our integral factor, remember, this one. So what are we going to simply do? We are going to substitute with the equivalent that we obtained for that integral factor, which is 1 over x squared in simplest form. Remember, this is the one that we simplified up to here. So that's 1 over x squared. All right, so it was going to be y times 1 over x squared, which is equal to the integral of, we have got this q. Remember, q is this part on the right hand side. So we are going to take that part as it is. That is 1 minus 3x over x times this integral factor, the same thing here, 1 over x squared. So that's it. So we're going to integrate with respect to x. We are done. So let's try to figure out this integral simplification. But as you can see, this here is just a matter of simplification. So here we can multiply y over x squared is equal to the integral of, here we can simplify. Let's just multiply the numerator to the numerator, denominator to the denominator before we can perform any integral. So that was going to be 1 minus 3x over what? So if we multiply these two x and x squared, that is x to the exponent of 3 with respect to x. Now that we have got this integration, we need to integrate. But the question is that possible for us to integrate this whole fraction as it is? It's gonna have complications. but we can separate as we have got these two terms. We do understand a plus b over c is going to give us a over c plus b over c. So thus we can separate each and every term over what? X to the exponent of 3. So that was going to give us y over x squared is equal to the integral 1 over x to the exponent of 3 minus, we're going to have 3x over x to the exponent of 3. So thus we have got separated with x to the exponent of 3. Since these are single terms that we have, we can actually look for a way out in our integral. Basically, if we are to consider the basics of our integration, a certain term raised to a certain power, that is the only way out. So we are given 1 over x to the exponent of 3. We can rewrite this as x to the exponent of negative 3. So we can do those simplifications, guys. So that is what we are going to have here. And for the 3x, so there we have got minus the 3x over x to the exponent of 3. We can reduce this one, x into x cubed. It's going to give us x squared. And rewriting as a negative exponent, it is going to be 3x to the exponent of what? Negative 2. So this is what we are going to have if we simplify this part. We haven't started integrating yet. We are just simplifying so that we can integrate properly. As we can see, our terms raised to a certain power, we can integrate as we do understand in that consideration. We just need to add 1 on our exponent. So n plus 1 over n plus 1 plus c. So that is the condition. We can integrate when it is like that. So that is it. If we add 1 here, that is going to be x to the exponent of negative 2 over negative 2, like this. But you do understand, guys, a negative exponent is same as what? 1 over. So it was going to be 1 over negative 2x squared. So this is the same as negative 1 over 2x squared. Okay, we do the same thing. If we were to integrate this, we add 1 on our exponent. So it was going to be negative 3x to the exponent of what? Negative 2 plus 1. That's negative 1 over that exponent, negative 1. So this and this going to cancel. So this is going to give us 3. X to the exponent of negative 1 is same as what? 1 over x. So this is going to give us plus. Remember the negative cancelled. So that's going to be plus 3 over x. All right. So this is the idea. We are done integrating this part. So you can add the constant of integration on your last part. As they asked to determine the general solution, guys, there is no need for you to simplify further there. Simplifying further, it is now in your hands. You have the general solution already. This is our general solution. It is not the particular solution where we are now supposed to determine the value of C for a certain condition that you are given that you must use there. In this case, we can leave our answer as it is. All right, so these are the steps, procedures that you need when you are working with the differential equations, the first order linear differential equations. First, it is the order that you need, the format, rewriting in the given format. Then you determine your integral factor, which you are going to need on this part. As you saw, it is given in your formula sheet. So you just substitute as it is. You simplify further by integrating the right-hand side until your answer is in the simplest form. So the thing there is just to simplify until your answer is in simplest form. So that is it on the first part. Let us consider the second question on our differential equations. On the second part, 4.2, which was a 7-mark question, find the particular solution. This time the constants has to be calculated if there are any constants. The particular solution from the second order differential equation. We're now given second derivative of y with respect to x. So for that, we must have or we must determine what we refer to as the auxiliary equation. All right. So first of all, it is the format. All right. Let's just take our equation as it is. The second derivative of y with respect to x plus 4 dy dx minus 12y is equal to 3e to the exponent of 2x. So we are going to look into these conditions later on as we are to determine the particular solution. All right, so this is what we are having here. The format first of the second order differential equation. This format is the one that is going to give us the auxiliary equation. So that is the first thing that we are going to need to form or to find. All right, so let us say form the what? Auxiliary equation. How do we find this? We are going to form it by we let some of these part of our derivatives and also the part of y. Okay, let us just consider as it is. So the y dx, we are going to let that one to be equal to r. Some they use the letter m, some r there, so you're gonna use the one that you want. But in this case, I'm just gonna use r as it is the one that you're also related to from your formula sheet. So these typical solutions that you are going to have on what is referred to as the complementary function. So the complementary function is from the solutions from solutions. This one's taken from solutions of the what? Of the auxiliary equation that we formed that one. So as we can see, they gave us these solutions in terms of R, in terms of R. So I'm just going to use that one. So some textbooks, they use the letter M. Depends, guys, with the textbook that you are using. So I'm just going to use the letter R for dy dx. Okay. Then we are going to let y to be equal to 1. So we let y to be equal to 1. And this part, which is of our f of x, this whole part, it represents our f of x. We are going to let that one to be equal to 0. That is the condition that gives us what? The auxiliary equation. So it means where I see this one dy dx, guys, it's just like this dy dx squared. So it is r squared. Remember, it is represented by what? By r. So you're going to have r squared plus 4 dy dx is represented by r there, minus 12 times, remember y is 1, so that's 12 times 1, which is minus 12, and that's equal to 0. Remember, the whole part of our f of x is now equal to what? To 0. So we have formed an auxiliary equation that must be solved. So we must solve for what? For r. That's a quadratic equation. We can use a quadratic formula, or we can just try factorization. So looking into minus 12 there, I can see that there's something relationship between minus 12 and 4. So I can just use my factorization. Since the coefficient of r squared is 1, it means I'm just going to have r and r here. Let's consider the factors of our constant. What is our constant? That is minus 12. So we need products of minus 12. These products must add up to positive 4. All right. So negative 12, there is negative 6 and 2, 6 and negative 2. Of these, the one that will add up to negative 4 is this one. If we add here, we're going to get positive 4. So that is it, positive 6, negative 6. So that is the brackets that you're going to have. And from these two brackets, we can solve for r as each bracket is equal to 0. So r is equal to what? 6 is going to give us a negative, or our r is going to be negative 2 is going to give us what? A positive 2. So these are the solutions. We can call this one r1 and this one r2. Are they equal or not? These solutions, they are not equal. R1 is not equal to R2, and they are not complex solutions, all right? Because we can have complex solutions. Remember this part where R is a complex from complex numbers when it is giving you a complex solution. Or we can have R1 being equal to R2, but in our case, R1 and R2, they are not equal. So this is the one that we are going to use on our presentation of the of our complementary function. So from those solutions, we find the complementary function. Okay, so let us take this one. So that's our complementary function from these solutions. Our complementary function, therefore, is going to be given as what? So therefore, our complementary function yc is going to be taken as e to the exponent of r1x plus b e to the exponent of r2 x. So this is the condition from our r1 and r2, those two solutions which are different. So we can substitute these. So that's e to the exponent of our r1 as we had from these solutions. It is what? Negative 6. So that's negative 6x here plus b e to the exponent. Our r2 is what? Is 2. So it's going to be 2x. So this one is going to depend. Maybe your r1 is 2, your r2 is negative 6. You put the way that you obtained from your solutions. All right? Because if it depends on the order of your solution, which one was the first bracket, that one can affect your answer in terms of the presentation. Not to say our answers, they are different. No, they are not different. They are just the same, just the presentation. So what you just read is where there is negative 6 x, what is going to be the value of a? Where there is 2x, what is going to be the value of that b? That is the most important thing later on. So do not worry about that. Okay, so we have got the complementary function from our auxiliary equation. So this is what we are going to do. We are going to leave this part as it is. We have got a and b as unknown. They are unknown values. So we are going to leave this part as it is. We are going to take it later on, combining to form what is called the general solution, which is going to be taken from the sum of the complementary and what we refer to as the particular integral, which we do not have for now. So this one, just leave it as it is, all right? So let us find what we refer to as the particular integral. So the particular integral, okay, how best can I explain this one? Because the particular integral, we are not given. The particular integral, it is taken from this f of x. From here, this one, our f of x. So I want us to see properly what is on our f of x. That is where we can have our particular integral, all right? So this is it. I want us to see something here. We must find what? The particular integral. We must find yp, which is our particular integral. Okay, no problem. So that yp is taken from f of x, from f of x. The way our f of x is given, because our f of x can be given as a linear, it can be a linear. Our f of x can be a quadratic function. Our f of x can be an exponential. So when we have the condition, or it can be a constant. So let's say it was y is equal to, maybe that part is 2x plus 1. It's a linear. So when you take this one, it is going to be given in the form of, remember, y is equal to mx plus c. So as we're going to take it as cx plus d, the format that we are given here, the constant cx plus another constant, since we have utilized a and what? A and b. So we take it as cx plus d. But in this case, it is not a linear. I'm just giving you an example. It's not a linear. But I'm just saying your f of x. So our f of x is what? An exponential, which is this one. All right. To the exponent f of x, it is 3 to the exponent of 2x. If you have an exponential like this, you must be very careful, because the solutions are not direct as we expect it. All right. One, you must consider to say your particular integral, when it is an exponential, it was supposed to give you something like c e to the exponent of kx. All right, since we've got a and b. So it was supposed to give us something like this. But we must check now to say the part of our f of x here, which is the part that we are going to look into our particular integral, is it having anything from what we obtained on our auxiliary, from those auxiliary values that we had? Remember, here we formulated our complementary part. So the question is, from that, are we having anything common from our complementary function? Because we have got our complementary function there. It has got e also. There is e to the exponent of -6. There is e to the exponent of 2x. So if we check properly, on our original function, on our f of x, you have the part of our particular integral. There is also e to the exponent of 2x, which is found here. It is there. Guys, we can have a condition like this. Let me put it this way. We can have a condition where we solve our auxiliary equation properly. Then let's say our values were given as x. Let's say these values were x. Let us just say R1 is equal to -6. And we have got R2, which is equal to 3. They're different. We're going to have our complementary function as e to the exponent, a e to the exponent of -6 plus b e to the exponent of 3x. This is what I'm trying to say. There is e, there is also e here, an exponential, but they are raised to certain powers which are not even the same to our f of x from that complementary function. But in our case, 2x, this e to the exponent of is the one that is making a difference. This one, being same, that one, to say your f of x and this part of your complementary function, there is something common. Once you see that, you are going to adjust your yp. You are going to have your yp. So therefore, our yp is going to be given as cx. We multiply it by x. So it will be cx e to the exponent of kx. Cx. You multiply it by x when it is like that. That is the condition. So you must be very, very, very careful there. Very, very careful. So in our case, therefore, so here, therefore, so that's therefore. So this is stage 3. So therefore, yp is equal to c x e to the exponent. Our kx, guys, is the one that we just did from our f of x. Remember, it was what? 2x. So that is 2x, the one that we are referring also here, the same here, 2x. All right. So that is our yp. So with our particular integral now, the difference is, remember, it was taken from f of x. So what are we going to do is to find the value of c from there. Remember, they say they want the particular solution. We must find all these constants from the particular integral as it was taken from our f of x. And we are saying this is y is equal to, we must find the same thing to say this is y. We must find the derivative of y with respect to x. We must find the second derivative so that we can substitute and find the value of c into the original equation. So that is from our particular integral. So let us try to find the value of c. So to find the value of c, we must follow those integrals. This is y. So we are going to find the derivative of y with respect to x. All right, this is a product. So if y is equal to u of v, the derivative of y is going to be, so you can have u, the first derivative of v, plus v, the derivative of u. So that's u, this is our v. So we're going to need u, which is cx, times the derivative of v. We drop the exponent to e to the exponent of 2x, plus our v as it is, times the derivative of u, which is cx. It's just like 2x. So the derivative is going to be 2. So ours is what? It's x. I mean, it's c. All right. The one that represents a constant, which is our 2. So this is what we are having, which we can simplify. 2 times this cx is going to be 2cx e to the exponent of 2x. All right, c times c here is going to be plus c e to the exponent of 2x. So we have got the y, we have got the dy dx. We need the second derivative as it is from our original question. So we're going to find the second derivative of y with respect to x of this particular integral. So as we are to differentiate, this is our resultant, remember. So we are talking about this. We must differentiate that. So differentiating here, this one is a product. So there is our u and our v. So remember the product, we already have our formula here. So it was going to be u, which is 2cx times the derivative of our v, which is the exponential 2e to the exponent of 2x. All right, so plus v, our v, which is e to the exponent of 2x, times the derivative of u. Our u is this 2cx. So we're going to take the constant, which is 2c. Okay, so we are done with this one, the product. But remember, there's this one at the end, the c. So there we're just gonna drop the exponent 2 to multiply c e to the exponent of 2x. So that's it. That's it. We have got our second derivative, just that we need to simplify it. Okay, so let us just try to simplify this one. 2 times 2, that's 4. So it's going to be 4cx. All right. E to the exponent of 2x plus the 2c. All right, these are actually the same. These are actually the same. That is e to the exponent of x and e to the exponent of this one, e to the exponent of 2x, e to the exponent of 2x. They are the same. We can add this one, the 2c and the 2c. So 2c plus 2c is going to give us what? 4c. So you can even combine that one. So that's 4c e to the exponent of 2x. So this is it. We have got the derivative of y with respect to x and its second derivative here. So this is what I'm trying to say. You take these into the original equation, y, the dy dx, the second derivative, in place of what we have there on top. All right. So let me, guys, remove these other things that we did previously into our original. This is our original equation, guys. Remember this one as it is here on top. You substitute everything as it is. You are going to form an equation where you can find the value of c. So from that original equation, we must substitute these values from that original equation, from that original equation that we were given. We must substitute everything. So it was 18, or it was 3, it was 3e to the exponent of 2x. So this was our original equation. From that original equation, in place of the second derivative of y with respect to x, we have that second derivative of y with respect to x from our particular integral. So we substitute it as it is in place of that dy dx. So this is what I'm trying to say. From that, we're going to substitute dy dx with its equivalent, 4cx e to the exponent of 2x plus 4c e to the exponent of 2x plus 4 times our dy dx. So our dy dx, remember, it is this one that we have here. This is our dy dx. So we're going to multiply everything by what? By 4. On what we are given here, we must multiply by 4. So it's going to be 4 times 2, which is 8. All right, let me reduce. I do not want to have a lot of things here. So let us just multiply. So it's 4 times 2, which is 8cx e to the exponent of 2x. All right, 4 times this c. So it's going to give us 4c e to the exponent of 2x. All right, we are done with our dy dx. Then it's minus 12y. Remember, y is our yp. This is the one. So our yp, we multiply by minus 12. So it was going to be simply minus 12. We multiply to that y as it is the cx e to the exponent of 2x. So it's going to give us cx e to the exponent of 2x. All right, we are done with everything. So this is equal to our right-hand side, which is our f of x. From f of x, you see, guys, from f of x, we want to equate to that f of x again. You see what our f of x is doing, guys. With this, we can determine, we can solve the value of c, for the value of c. By equating, we can look into this, the left-hand side and right-hand side of our equation. On the left-hand side, on our right-hand side, we have got 3 as a constant here. We do not have x. So we are going to equate this part to the left-hand side to any part as long it is having e to the exponent of 2x, but being constants where we do not have x. Where we do not have x here, we do not have x. The first one, there was x there. Here, there is x. Here, there's x. We do not want that. Where we do not have x, here, we do not have x. All right? Here, there is x. So we just want the condition of a constant. So what is on the left-hand side as the constants is exactly the same as what we have on the right-hand side also as our constants. So therefore, we can say 4c plus this one, 4c is equal to 3. 4c plus 4c, that's 8c, which is equal to 3. So dividing by 8, that was finding the value of c. So our c is going to give us what? 3 over 8, just like that. So this is finding the exact value of c so that we can put it back to that particular integral that we said let it be written as. Remember, all we just needed there was to find the value of c. With this, it was to find this value of c. This is the condition that you must have, all right? Now that you've got your value of c, which is 3 over 8, so therefore, we're gonna have our yp in exact form as what? So therefore here, yp is equal to, since we've got this c as 3 over 8, so that's 3 over 8x e to the exponent of 2x, okay? So this is what we have as our particular integral. With the complementary function that we obtained before, we can combine these two to form what we refer to as the general solution. So the fourth step is to find the general solution from this whole thing that we just determined. All right. So our general solution is a combination of these two, the complementary function and the integral, particular integral. So that's yc plus yp. You can combine these two. Yc as a e to the exponent of negative 6x plus b e to the exponent of 2x. Adding our particular integral, which we obtained in exact form, we have got the value of c. So we're going to write that one, 3 over 8x e to the exponent of 2x. That is your general solution. So guys, having this general solution, it means all this part that we were having before is useless. We are done with these calculations, these ones. We need that information now that we were given here before to answer our question. So those were the steps, guys, that you're going to take for the sake of time. For the sake of time and also space, I'm just going to remove everything that we had. So this is it. With that general solution, because the general solution is the one that will give us the particular solution at the end. So you have your general solution, remember? So you're going to take that general solution. All right, it was y is equal to, from yc plus yp, remember we got a to the exponent, ae to the exponent of negative 6x plus b e to the exponent of 2x plus 3 over 8x e to the exponent of 2x. This is the one that we need, guys, to determine our particular solution, as they gave us the first condition Derivative of y with respect to x is 2 when x is 0. And another condition, y is equal to 1 when x is 0. This one, it's a condition on its own that we can use, because our general solution so far, we just have y and x. So let's use it. In place of y, we substitute that. In place of y, we substitute, since y is equal to 1 when x is 0. So let's substitute in place of y. That is going to give us 1 is equal to, guys, remember that any number to the exponent of 0 is what? It's 1. So this was going to give us 1 times a, which is a. This was going to give us 1 times b, which is b. So we have got a plus b. All right. And here, the moment we put a 0, since x is on a product here, the moment we put a 0, whether it was a 1 here, but the moment you multiply any number by a 0, that one is going to give us what? A 0. So that is it. So this is what you're going to have as your first equation. As we can see, we have got two unknown values which we cannot solve direct. So we have to leave it like that. So to form another equation, it means we must have, or we must utilize this condition of the second derivative, I mean the first derivative here when x is 0. It's dy dx. We must have the derivative. Here it was y and x. But this one, we must have the derivative. So let us find the derivative of y with respect to x from our general solution. So finding this derivative, we're going to drop the exponent on e to multiply this. So this is negative 6a e to the exponent of negative 6x. All right, we move on to the part of b. So there's 2 there, we drop it. So that is going to be 2a e to the exponent of 2x. There is a product on this one, so we must consider that product as before. All right, so that is a product. Let us just have our two terms. This is our u, and this is our v. So remember, we say the derivative of y is going to be u, the derivative of v plus v, the derivative of u. So meaning to say, if we were to apply this, our u is what? 3 over 8. All right, let me just rewrite it down. 3 over 8 x times the derivative of v, which is our e. So we're going to drop the power there. We are used to this one, 2e to the exponent of 2x. All right, so this one, it is just a single term. All right, plus our v, which is e to the exponent of 2x times the derivative of u. If we differentiate 3 over 8x, it's going to give us what? 3 over 8. So that's 3 over 8. So this is what we are having there. With this derivative, we can now substitute the condition that we are given, because they are saying for that derivative, it must be 2 when x is 0. So we can use our condition that the derivative of y with respect to x is 2 on a condition where x is 0. So the derivative of y with respect to x is what? Is 2. When our x is 0, remember any number to the power of 0 is going to give us 1. So it will be negative 6a times 1, which is negative 6a. This is going to give us a 1. So 2a times 1 is what? Is 2a. Is that 2a or b, guys? The b... All right, this is B here. This is B. Let us correct this one. This is B here from this one. So that is going to give us 2B there. So this one is going to give us 2b times 1, which is 2b. Okay. Then we check another part. The x here is on a product. So the moment we have a product, any number times 0, we know that this whole thing is going to give us a 0. All right. E to the exponent of a 0, it's 1. So 1 times 3 over 8 is going to give us what? 3 over 8. That one, we are going to have it on our final answer. So this is our second equation, which we can just try to simplify before we solve. We can take the minus 3 over 8 to the other side. 2 minus 3 over 8, which was going to give us 13 over 8. So 13 over 8 is equal to negative 6a plus 2b. There's something that we can see, guys. We are to solve later on. We can see that b here, and there is a 2b. The moment we can divide by 2, we can form an equation that we equate in terms of what? In terms of b. So let us just divide here. 13 over 8 divide by 2 is going to give us 13 over 16 equal to negative 3a plus plus b. So this is our simplified equation that we can say our equation 2. So this is what I'm trying to say, guys. Since we have got these equations, equation 1 and equation 2, we can simply solve by substitution or by just having b as the subject. Okay, if you check equation 1, solving here, guys, is in your hands. So I'm just going to take advantage of equation 1. From equation 1, I can have b as the subject if I take a to the other side. So it's going to be 1 minus a is equal to b. So I want you to see this one. B is equal to what? 1 minus a from equation 1. From equation 2, we can also do the same because we've got b there, which is equal to this part. So we can simply say the negative 3 to the other side. So it will be given as 13. So it's going to be like this. 13 over 16. We take the minus 3a to the other side. So it's going to be positive. So that's positive 3a is equal to b. Remember that part when you're dealing with your functions, when there are two equations, y is equal to this equation of y, and there's another y which is equal to where you equate the part of x. It is the same thing that I want us to have here. We have got b written in terms of a from both equations. This one is b. The other one here, it was also a b. If we check this one that we formed here, this one, we can equate because this is b which is equal to this, b which is equal to this. These two, they are equal. So therefore, we can say we have formed an equation in a that we can use to solve for a from that. So we can say, therefore, this one, 1 minus a is equal to what? 13 over 16 plus 3a. So that's an equation that we can use to solve for a. All right. I can take the 13 over 16 to the other side. So that's going to be 1 minus 13 over 16, which is 3 over 16. So that's 3 over 16, which is equal to, I take the minus a to the other side. So it's a minus. It's going to be positive a there. So 3 plus a. 3a plus a is going to give us what? 4a. Okay, so that's it. With this, we can solve for a, divide by 4, or simply multiply by 1 over 4. 1 over 4, so this can cancel. So our a is equal to what? 1 over 4 times this, or dividing by 4, it is going to give us 3 over 64. 3 over 64. So this is our a, which we can substitute in any of the equations. You go back to equation 1, whatever, equation that you are given, or you can even substitute direct where we've got b as the subject. Remember I said b is equal to what? B is equal to 1 minus a. So therefore b is 1 minus the a that we calculated, 3 over 64. So that was going to give us the value of b, and that's 61 over 64. With these values, as we have got the value of a, the value of b, we can substitute. Remember that general solution, our general solution here. So that is going to give us our particular solution at the end. So it's unfortunate here, guys, when I worked this question, I was erasing a lot of things as we had also a lot of things on our question. So as our final answer, you're going to substitute. So therefore, our particular solution is going to be given as y is equal to, in place of a, you substitute the a that you calculated here, which we got as a, we said our a is what? 3 over what? 3 over 64. So this is 3 over 64 e to the exponent of negative. So you can simply substitute these values, which is the b. Our b is given as 61 over 64. All right, so that was going to be 61 over 64. All right, e to the exponent of 2x. So this one is already in simplest form, which is 3 over 8 x e to the exponent of 2x. So that is it. We have got our particular solution, which is in its simplest form. So the questions there are just that you need to focus on the steps. Which steps are you supposed to consider as you are to have the particular solution at the end? You must follow all the stages that is from the auxiliary equation, which we are going to use in order for us to determine our complementary function, then determining of the particular integral, combining the two to determine what we refer to as the general solution, then finding of every constant. It is very, very important. So these are the typical questions that you might have on your final exams.